Hey everyone. So lately we have been doing a lot of graphing. Today we're going to go back to some algebra and solve trig equations. All right. So we are on page 265 of your Springboard book, but we are actually going to skip that first page. All right. And we're going to go straight to page 266. All right. And go ahead and skip down to example A down here. And we're just kind of jump right into it here. So we've already talked about in activity 18 how to find this x value. You basically are finding the inverse of cosine right here, right? So cosine equals the square root of 2 over 2 at pi over 4 and at 7 pi over 4 over the interval from 0 to 2 pi, right? And if we want to show that that keeps happening at pi over 4, if I add 2 pi to that, that gets me back to the same spot. So that's where that says 2 plus 2 pi in k means like any integer. So if I put a 2 there, that means plus 4 pi. So that means I would do 2 rotations. And even after 2 rotations, I end up in the same spot, right? Same idea for 7 pi over 4 down here, okay? So that's just kind of to get you guys like started, a quick little example there. But I think once we start doing these, we'll get the hang of it. We're just going to jump into it. I will say, though, we do want to have this plus 2 pi k because for sine, we are over the interval of from 0 to 2 pi as well. And I'll talk more about that as we get in. So, all right, try these. Letter A, find the general solutions of each equation. So, where on the unit circle does sine equal negative 1/2? Well, if I just draw a quick little sketch here, that is at 11 pi over 6 and at 7 pi over 6. Okay, so to show that no matter how many times I go around the unit circle, that it's always going to appear there, we're going to say x equals 7 pi over 6 plus 2 pi k. All right, because no matter how many times I rotate around it, I end up in that same spot. And then x also equals 11 pi over 6 plus 2 pi k. Now, the reason why we're saying 2 pi is because 1 period for sine is 2 pi. Okay, just like 1 period for cosine was 2 pi. All right, so for tangent down here, where in the unit circle is the tangent value square root of 3, or yeah, the square root of 3. Sorry. Okay, and that happens at pi over 3, right? Okay, now that also would happen down here as well because a negative y value and a negative x value make positive. However, tangent, 1 period of tangent is pi. So I can really only go from 0 to pi for tangent, all right? So this is actually just going to be x equals pi over 3 plus pi k, where k is an integer, because I'm just focusing on 1 period for tangent. So remember, sine, the period is 2 pi, cosine, the period is 2 pi, tangent is his own little guy. He has a period of pi. All right, those are just finding general solutions. Change the page. Okay, now we're going to solve some trig equations that have a little more stuff involved here. So example B says solve for cosine of x plus 9 equals 11 over the interval from 0 to 2 pi. So we will give you an interval to solve those on. Almost think of this as just like 4 instead of cosine of x, just as an x, plus 9 equals 11. So if that was the equation, you guys would just subtract 9, divide by 4, and you get your x value, right? Same idea. I'm going to subtract 9, so I get 2, and then if I divide these both by 4, 2 over 4 is 1/2. And then you guys know what the cosine of x equals 1/2 is, all right? That's at pi over 3 and at 5 pi over 3. So think of it as just an algebraic equation. Now you just have a trig function word right there, okay? Example C, this is a sine example. Notice here you have sine squared x plus sine of x equals 0 over the interval from 0 to 2 pi. Think of this as just x squared plus x equals 0. Notice you can factor out an x term, right? And then once you factor, you can set your factors equal to 0. So that's kind of what's happening here. Instead of factoring out x, we're factoring out sine. And then you would be solving sine x equals 0 and sine x equals -1 because you'd have to subtract that 1 over. Okay, and that happens at 0, pi, and at 3 pi over 2 if you look back at your unit circle. All right, let's do some examples together though down here. So it says find the solutions of each equation over the interval from 0 to 2 pi. So we know we're looking from 0 over to 2 pi. On the front side, that was just kind of to get us started. So don't get too caught up on the 2 pi and the pi. That's just more for general solutions. Now we're finding the exact solution, okay? So letter A, let's do that guy. Let's do that over here. All right, so I have 8 cosine of x plus the square root of 3 equals 5 square root of 3. All right, I'm going to subtract the square root of 3 first because this is really just 8x plus the square root of 3, right? So when I subtract the square root of 3, I get 8 cosine of x. These cancel, equals, this is really just 5 minus 1. You subtract the coefficients. So this is 4 square root of 3. Okay? Then I'm going to divide both sides by 8. So I get cosine of x equals, I'll show my work, 4 over 8. That's 1/2. So this is square root of 3 over 2. So I like to ask myself, okay, I know that the square root of 3 over 2 for cosine is right here and right here on the unit circle. So this is at pi over 6 and at 11 pi over 6, right? So x equals pi over 6 and x equals 11 pi over 6. And I can say 11 pi over 6 because I'm on the interval from 0 to 2 pi. So just be careful of that. All right, next example B. I have tangent squared x plus 2 tangent of x equals -1. Now when I first see this, thinking back by example C, it kind of looks like I want to factor out a tangent, right? However, if you guys look at this as like x squared plus 2x equals -1, if I add this 1 over, I can just factor this, right? Once you have an equation say equal to 0, you can factor that. That's a quadratic because it's x squared. So I'm going to kind of think of it like that. So I'm going to do tan squared of x plus 2 tangent of x plus 1 equals 0. And now I'm just going to factor this. All right, what times what will give me tangent squared x? Tan of x, tan of x. Whoops, put tax. All right. 1 times 1 give me 1. And then if I FOIL this out, if these are both plus signs, I would get in the middle term, when I combine my like terms after FOILing, I would get 2 tangent of x. Okay, so those are my factors there. Notice they are the same factor, so I don't have to solve it twice or write it twice. So I'm just going to write tangent of x plus 1 equals 0, and I'm going to solve. So I get tangent of x equals -1. So that occurs in 2 spots. Let's look at where that happens. So that's when the x and the y values have to both be the same. So that's at the 45-degree angles. And I know tangent has to be negative. So tangent is negative. All scholars take calculus here and there, right? So this value is, this is 3 pi over 4. So x equals 3 pi over 4. 3 pi, 4, 5, 6. This is 7 pi over 4. Okay? Alrighty. On to the next page. Alright. Solutions to trig equations can also be given in degrees. So, in this next example, it says solve 2 plus secant squared of theta equals 6 over the interval from 0 to 360. compare this to solving the equation 2 plus x squared, just think of that as x squared, equals 6, right? You would subtract 2 and then take the square root of 4. Here we would subtract 2 and then take the square root, and then we would just have to find that angle measurement where that happens, right? So let's take a look here. We've got 3 practice problems we're going to do below together. So, not a lot of space right here, but 2 sine squared theta minus 1 equals 0. Okay. I'm going to add 1 to both sides first because this is like 2x squared minus 1. So 2 sine squared of theta equals 1. And then I'm going to divide both sides by 2. So sine squared theta equals 1/2. All right. And then I'm going to take the square root of both sides. So I get sine of theta equals plus or minus, and then you're taking the square root of both the numerator and denominator. You guys should know, let me scoot that up a bit, that when you're taking the square root of a denominator, you guys know to rationalize, right? So this is actually plus or minus the square root of 2 over 2. I'm just going to rewrite that again to make it look a little nicer. Okay. Now, I'm not going to show my work on that every time because I think some of you guys have caught on to some of those patterns as well, but I will just for that first example right there. Why is this turning on me? There we go. All right, next. So we need to figure out where that happens, right? So sine square root of 2 over 2, the positives are in those 45-degree angles, right? Well, then I also have the negatives. That happens twice down here as well. And we're looking the intervals over from 0 to 360. This is 0, a full circle is 360 degrees, so I'm looking at the whole unit circle here, right? So now you just list out those angles. So this is when theta equals, let's see, that's 45 degrees. This is 135 degrees. This is 225 degrees. And this is at 315 degrees. So those are your solutions there for letter A. Okay? All right, let's try another one. Letter B. We have -6 cosecant theta minus 7 equals 5. So let me add that 7 over first. Cosecant theta equals 12. Right? Okay. Then I'm going to divide both sides by -6. So I get -2. Alrighty, so this one's a little trickier. I'm just going to make some side notes off here to the side. Okay. Let's see. So cosecant, that is the reciprocal of of sine, right? So that's like 1 over sine there. And so basically this is saying when that's 1 over -2. Okay, that would be the reciprocal of that, right? So I just kind of want to find where sine is -1/2. So that, if I look at my unit circle, that happens here because it's when the y value is -1/2, right? So that is actually at 210 degrees. And that happens at 330 degrees. All right. And the last example, letter C. We have 9 cotangent squared theta minus 3 equals 0. Okay. All right, so I'm going to add 3 to both sides, get rid of that junk. Then I'm going to divide both sides by 9, so cotangent squared theta equals 3 divided by 9 is 1/3. Apologize for that. All right, then when I take the square root, I'm going to get cotangent of theta equals, okay, so the square root of 1/3, again, you can think of that as square root of 1 over the square root of 3. Okay, I'm going to end up with the square root of 3 in the numerator and just 3 in the denominator. And remember, when you take the square root, you have plus or minus. Then I just need to find out where that happens on the unit circle. So let's just do that off to the side over here. Let's see. So cotangent Again, this is a reciprocal, so I got to think a little bit more here. So that is 1 over tangent. All right. And so really you're doing 1 over that guy. So the square root of 3 over 3. And that actually just equals the square root of 3. So let's find out where tangent is the square root of 3. That happens at the thirds mark. So it's here and here. And actually I want the positive and negative, so it's going to be at all like the thirds marks on your unit circle. So that in degrees is theta, that's 60 degrees, right? And this is 120. This is at, golly, 240. And then this is at 300. If you ever get stuck, remember this is 0, 90, 180, and then 270. And this is also 360 if you need to think of it like that. So maybe that might help you guys. All right. So if you guys have any questions, let us know. You can also kind of like look at these in terms of triangles. All right. So whatever helps you figure it out, do that method. All right. Your homework is on this page. Let me double check the homework assignment. I can't remember off the top of my head. 5 through 7 all. Okay. So just 5 through 7. All right, guys. Let us know if you have any questions. Bye.